At this point, we've talked about the y-intercept of quadratic functions. We've talked about the concavity type. Let's talk about where we cross the x-axis. So where's our x-axis intercepts, or the x values that's going to return a 0 inside the function? You can see here from this picture that this graph is only going to have 1, 0. It only crosses your x-axis at one point. And let's show that using the quadratic formula. So if you have a function that looks like ax squared plus bx plus c, if you have a quadratic function, then the zeros, so the x values such that the function is going to give you a 0, or you're going to cross your x-axis, are given to you by opposite b plus or minus square root b squared minus 4ac all over 2a. Now, it seems kind of ridiculous for me to ask you to memorize that, but you will memorize it just by using it so often. This is a very popular thing to ask for the zeros of quadratic functions because they're so easily solved for, right? I can give you any quadratic function and you can solve for the zeros by using this equation. So let's apply this equation to our example. So that's my quadratic function. The b value is -8, so minus a -8. And then I plus or minus a square root. B squared is -8 squared minus 4 times a, which is 1 in this case, times c, which is 16. And then make sure that all of that is over 2a. Okay, let's run through the algebra. So we end up with an 8 plus or minus square root 64 minus 64 all over 2. That gives us 8 plus or minus square root 0 over 2. 8 plus or minus 0 over 2. So that just gives us 8 over 2, right? Because plus or minus 0 is the same thing. So this is why I could have gotten 2 answers, but I ended up only getting 1 answer, because the discriminant, the b squared minus 4ac, resulted in just a 0. So I only have one x value that makes this function 0, and it happens at x is equal to 4. And that's exactly what we see from our picture.